Hi, and welcome to practice problem 2 from part 2 of your Half-Life practice. So, remember with these problems, it's the same process each time. You read, you identify your given and your find, and then you use your find to figure out which equation you're going to use last and which one you're going to use first. And then you plug it in and use algebra to solve. So this problem reads, potassium-42 has a half-life of 12.4 hours. How much of an 848 gram sample of potassium-42 will be left after 62 hours? And that's the only question I'm going to show you here. You can ignore the rest. So in this case, we're given the half-life, 12.4 hours. We are given the initial amount, 848 grams. We're also given the elapsed time, 62 hours. What we're asked to find here is what's the final amount. So if I'm asked to find the final amount, I'm going to use equation B last, because equation B has the final amount in it. So whatever I'm asked to find, I use that. Whatever equation has that, my find in it, I use that equation last. So I'll use last. That means I'm going to use equation A first. And I love it when I use equation A first. Well, I shouldn't say I love it, but in terms of not having to use logs, you don't have to use logs when you use equation A first. Now, whatever equation you use first, you are going to use that equation to solve for your half-life cycle. So that's always the first step. Use that, whatever equation you're using first, whether it's A or B, you're using that to solve for your half-life cycle. In this case, we're going to start with equation A. So I'm going to plug in my elapsed time, the 62 hours. I'm going to plug in my half-life, the 12.4 hours, and I'm going to solve for my half-life cycle. So the number of half-life cycles, which again is not the same as the half-life, it just counts how many half-lives have passed in that elapsed time. So in 62 hours, how many half-lives will pass if each half-life is 12.4 hours? So I go ahead and plug that into my calculator. 62 divided by 12.4. And I get 5. Oh, this is nice. Okay, so my number of half-life cycles equals 5. Okay, so 5 half-life cycles. All right. Now what we're going to do is we're going to take this information and plug it into our equation B, which is the final amount equals initial amount over 2 to the power of HLC. So let me just go ahead and write that. So F is for my final amount over my initial amount raised to 2 to the power of HLC. I'm going to plug that 5 into here, and then my initial amount is the 8.48 grams. I plug that into here. So what does that look like? I get final amount is equal to 848 grams divided by 2 raised to the 5th power. And when I do this, of course, I'm going to use my PEMDAS. So I'm going to do my exponent first. So 2 raised to the 5th power, and that's 32. So I get F is equal to 848 divided by 32. So I can just divide 848 by 32 to get my final amount. And I get 26.5. And I always need to check for my units here. So since I'm looking for final amount, the units I have are hours and grams. The unit for amount would be grams. So use the same when you're looking for the final amount, trying to find the final amount, you use the same unit for mass or amount that you're given in your initial amount. So that would be grams. And then that's it. That is it for that problem. So just a quick note. So whenever you are using equation A first, the half-life cycles equal the elapsed time of half-life, you won't have to use log. If you use equation B first, you do have to use logs because the your unknown, the half-life cycles, is an exponent. And in order to solve for an exponent, when your exponent is the unknown, use the inverse operation of that, which would be logs. Okay, that's it for this video. I hope you found this video helpful. Have a quality day.